For decades, humanity has looked up at the stars and deeply feared the cosmic giants we usually call black holes. We pictured them as the ultimate cosmic vacuum cleaners, dark abysses where light, matter, and time go to fade forever. But what if everything we thought we knew was a massive misunderstanding? What if they aren't cosmic graves, but perfect engines? A spinning black hole is not a hole at all. It is actually the most perfect, efficient gravitational engine nature allows. To understand this, look at our Sun. It powers the solar system using nuclear fusion, the exact same process inside our weapons. Yet, nuclear fusion is shockingly inefficient. It converts less than 1% of a star's total mass into usable outward energy. Now, let's look at a rotating Kerr black hole. According to general relativity, it can convert up to 40% of mass into pure energy. That is over 40 times more efficient than the stars themselves. It is the absolute limit of energy extraction in our known universe. Imagine this thought experiment. If you were to throw a simple lump of coal, or even household garbage, into a spinning black hole's orbit, the immense gravitational friction in the accretion disk would rip its atoms apart, rapidly heating the material to billions of degrees. Before that lump of coal even crosses the event horizon, it would release far more energy than a massive nuclear detonation. The black hole isn't eating the energy, it's radiating it outward. It is the ultimate power plant, just waiting to be carefully harvested. But there is a catch. The nearest known black holes are thousands of light years away. We cannot simply fly a power cord to them. If we want to conquer the galaxy and travel between the stars, we cannot rely on finding black holes. We must build our own. We need an engine made of pure light, a pocket-sized gravity monster known in theoretical physics as a Kugelblitz drive. To build our own black hole, we must master the universe's ultimate speed limit: light. Albert Einstein taught us that energy and mass are two sides of the same coin. If mass can be turned into energy, then pure energy can be condensed back into mass. In 1955, theoretical physicist John Archibald Wheeler proposed a radical idea. If you focus enough light into a microscopic point, the energy density becomes infinite. He called it a Kugelblitz, German for ball lightning. To create one, we wouldn't use rocks or metal. We would use a sphere of gamma-ray lasers. By firing billions of ultra-powerful lasers at a single, incredibly tiny focal point, the trapped light becomes so unimaginably dense that its gravity warps spacetime itself. The light collapses under its own weight, giving birth to a miniature black hole. A Kugelblitz is identical to a natural black hole, but crafted entirely by human hands. It doesn't matter what formed it. Once the event horizon appears, the light is trapped forever. But holding on to this artificial monster is incredibly dangerous, because the smaller a black hole is, the more violently it wants to explode and evaporate. We have built the ultimate engine. Now we must learn how to survive it. We have a black hole safely in a box. But there is a massive problem with miniature black holes. In 1974, theoretical physicist Stephen Hawking discovered that black holes are not entirely black. They slowly leak energy over time, a quantum process now known as Hawking radiation. And here is the paradox. The smaller a black hole is, the hotter it gets, and the faster it evaporates. A black hole the size of a single proton would weigh as much as a mountain, roughly billions of tons. But because it is so incredibly small, it would completely evaporate into nothing in just about 5 years. In its final moments, it would release a massive burst of pure cosmic energy, outshining a star. This means our Kugelblitz engine is basically a highly unstable cosmic energy core. To tame this micro black hole and use it for interstellar travel, we must constantly feed it. We have to precisely shoot matter, like dust, gas, or pure lasers, into its event horizon. The goal is to match the exact rate of its Hawking radiation, a perfect equilibrium. If we feed it too little, it dissipates. If we feed it too much, it grows too massive for the ship to carry. It requires a delicate balance, a cosmic tightrope walk performed by supercomputers. But if we get it exactly right, the energy output provides continuous, unimaginable thrust. With the beast finally tamed, we can start building the ultimate vessel around it. The blueprint reveals a megastructure, a spaceship not built to burn chemical fuel, but to harness a captive black hole. Since Hawking radiation shoots out equally in every single direction, we cannot just attach a standard thruster. Engineers would construct a Dyson cap, a massive, ultra-reflective dome built entirely around the forward half of the core. This acts as a perfect parabolic reflector. The intense gamma radiation hits the inner curve and bounces out the back. This creates a blinding, continuous beam of pure photonic thrust. It is the ultimate laser engine. Because the Kugelblitz core is incredibly heavy, weighing billions of tons, the ship itself must be the size of a city. Once activated, the acceleration wouldn't be a violent explosion. It would be a smooth, relentless, and continuous push. Over months and years of constant acceleration, this black hole arc would reach unimaginable velocities. According to physics, a Kugelblitz drive could comfortably push a massive starship to 10% of the speed of light. At 0.1 c, the ship is traveling at a staggering 30,000 kilometers every single second. At this incredible speed, our nearest neighboring star system, Alpha Centauri, is no longer an impossible dream. Current chemical rockets would take 70,000 years. The Kugelblitz arc would make the journey in just 40 years. It makes interstellar travel possible within a single human lifetime. We transform into citizens of the galaxy, but carrying a billion-ton artificial black hole inside your ship is incredibly difficult and highly dangerous. What if we didn't have to bring the engine with us? What if we could surf wild black holes instead? Instead of building a black hole and dragging it with us, we can use the ones already scattered across the galaxy. In 2019, astronomer David Kipping published a paper detailing a revolutionary concept. He called it the halo drive, a method to travel the cosmos without carrying a single drop of fuel. The secret relies on what physicists call a gravitational boomerang effect. When you find a Kerr black hole, one that is spinning at incredible speeds, you fly your spaceship near it and fire a powerful laser beam just outside its event horizon. The immense gravity of the black hole grabs the light, bends it like a slingshot, and throws the laser back at you. But something magical happens during this U-turn. The light steals rotational energy from the black hole. It returns to your ship, blue-shifted, packing more energy than when it left. Your ship catches this boosted light with a massive mirror, absorbing the extra momentum. This pushes your spacecraft forward with tremendous force, essentially getting a free ride from the black hole. You don't burn fuel. You just bounce light off gravity and let the universe do the heavy lifting. The black hole slows down by an imperceptible fraction, paying the price for your acceleration. Calculations show this halo drive could yield speeds over 130% faster than standard orbital maneuvers. We are no longer just flying through space, we are surfing the fabric of space-time itself. But how exactly does a beam of light steal physical momentum from a giant black hole? The answer lies in a mind-bending physics concept known as frame dragging. Imagine a spinning bowling ball dropped into a pool of thick honey. As it spins, it drags the honey with it. A rotating Kerr black hole does the exact same thing to the fabric of space-time itself. It creates a swirling vortex outside the event horizon called the Ergosphere. Inside the Ergosphere, space is moving so fast that it is physically impossible to stand still. Even if you had infinite engine power, you would be forced to orbit the black hole. When our laser beam enters this region, it's like throwing a tennis ball at a speeding train. The laser gets swept up by the spinning space-time, absorbs a massive amount of rotational kinetic energy, and bounces back. Because energy and mass are equivalent, taking energy away from the black hole means taking away its mass. By firing that laser, you literally shrink the black hole and slow down its rotation. An advanced Type 2 civilization could map out every Kerr black hole in the galaxy. They would use them as a cosmic highway, a network of free energy boosts to travel between the stars. But humanity's curiosity rarely stops at simply traveling faster. If we can steal a little bit of energy to move a ship, what happens if we trap all of it at once? Welcome to the dark side of astrophysics. The line between a perfect engine and a perfect weapon is very thin. In 1969, physicist Roger Penrose proved exactly how to mine a black hole using its ergosphere. It's called the Penrose Process, and it requires a very specific sacrifice. If you throw an object into the spinning ergosphere and split it perfectly in half, you can mathematically force one half to fall into the black hole, carrying negative energy. The other half is ejected outward, carrying more energy than the original unbroken object. You have successfully mined the black hole's rotational mass. You traded a piece of junk for pure power. At maximum efficiency, this process can extract up to 29% of the black hole's entire mass. That is an astronomical amount of energy. But to build our ultimate weapon, we don't throw rocks. We shoot a continuous beam of light into the ergosphere instead. The light steals the rotational energy, gets amplified, and bounces out. This triggers a terrifying physics phenomenon known as superradiant scattering. To turn this into a bomb, we must not let that amplified light escape. We trap it. We build a massive spherical mirror around the black hole. The light bounces off the mirror, dives back into the ergosphere, steals more energy, hits the mirror again, and repeats. With every bounce, the energy grows exponentially. Inside that mirror sphere, the light waves are trapped. They steal rotational energy with every single pass. This creates an aggressive feedback loop. The light becomes so intense, it practically turns into a solid wall of energy. Light actually carries momentum. When enough of it bounces around, it physically pushes outward. This is called radiation pressure. And inside this trap, it builds to unimaginable levels, stressing the mirrors. But you can control it. By opening a small window in the sphere, you can release the amplified light. You have just created the ultimate power plant, a limitless battery for an advanced galactic civilization. But what if you choose not to open the window? What if you let the energy build infinitely? The trapped light extracts more and more mass from the black hole. The pressure exceeds any known material. This is no longer an engine, it is a black hole bomb, and its yield is mathematically terrifying. To detonate it, you simply fly away, keep the window closed, and let the laws of physics do the rest. The mirror shatters. The confined energy escapes all at once in a catastrophic, brilliant flash of radiation. The resulting burst would easily rival a supernova, releasing more energy in 1 second than our sun will in its entire lifetime. It is an event capable of illuminating entire star clusters, sweeping across space in a wave of gamma light. And the black hole? It survives, but it has been robbed of its momentum, spinning much slower than before. We have turned the void into a cosmic weapon. But what kind of civilization could actually build this? To understand who could build a black hole engine, we must measure the evolution of intelligent life. In 1964, Soviet astronomer Nikolai Kardashev proposed a method to rank civilizations based on energy consumption. A Type 1 civilization harnesses all the energy of its home planet. Humanity is currently not even at this level. A Type 2 civilization controls the total energy of its host star, generating roughly 10 to the power of 26 watts. But stars are finite. They burn out, expand, and eventually die. To truly conquer eternity, you need black holes. Enter the Type 3 civilization. Masters of an entire galaxy, commanding a staggering 10 to the power of 36 watts. They wouldn't just build one Kugelblitz drive. They would harvest millions of black holes. They would weave a galactic grid of Penrose Process reactors, drawing endless momentum from the void. They transition from being mere inhabitants of the universe to becoming its supreme architects. And they will need this power, because the universe has an expiration date known as the heat death. Trillions of years from now, the last star will burn out. The cosmos will enter the dark era. In this absolute darkness, a black hole engine is the only way a civilization can continue existing. By dropping matter into the black hole, they can keep their cities illuminated long after the stars are gone. We always looked up at the night sky and feared the dark spaces between the stars. But maybe that darkness is exactly where humanity's ultimate salvation lies. But before we build galactic empires or surf on the edge of event horizons, we are still here, on a pale blue dot, struggling to leave our own backyard with chemical rockets. The concepts we explored today, the Kugelblitz, the halo drive, the Penrose process, they are not just science fiction. They are mathematical realities waiting for our engineering to catch up. The laws of physics actively allow us to extract infinite energy from the darkest voids. Black holes are not cosmic graves. They are the ultimate engines of the universe. All it takes is time, boundless curiosity, and the courage to look into the abyss without fear. Because the universe didn't build itself to trap us. It built itself to be explored. If you survived this journey to the edge of space-time, make sure to hit that subscribe button. Join our growing community here on Mio and Scholarbird for more deep dives into the cosmos. What cosmic mystery or ultimate weapon should we decode next? Let me know in the comments below. Until next time, keep your eyes on the stars and never stop questioning everything.